Welcome to Astronomy for Everyone. I'm your host, Steve Whitty. I'm filling in for Don Glaser this month. This month we will be talking about deep sky objects that you can see in the spring. This is March 2013. With me on the studio is Ken Anderson. So while I will be talking about how you can see these objects from a light-polluted area with binoculars or a 10-inch telescope, Ken has a different vantage. Ken?
Yes, and I'll be talking about the views from a moderately dark sky site with my 17.5-inch diameter Dobsonian, so it'll be an advanced telescope and also larger binoculars.
Very good. Our very first object is a globular cluster in Canis Venatici, and it's M3. So, I guess I'll start out here. Globular clusters in general are stars. They are fairly easy to see in binoculars or telescopes from anywhere you are, and it doesn't really matter that much. So M3 is a great globular cluster, and it's relatively easy to spot. Canis Venatici is in the north. It's nearly circumpolar, so you can see it almost all the time. Ken?
Yes, all globular clusters look really good in any type of telescope, and the larger telescopes bring out more of the light, and you can have a higher power eyepiece and basically fill up the whole view. It looks really awesome. It's magnitude 6. It's very bright. It's 35,000 light years away from us. Its apparent size is 21 minutes, but in real life it's 214 light years all the way across it.
Yeah, so 21 minutes, that's about 2/3 the way across a full moon, just for comparison. There are about 500,000 stars in this globular cluster. It's a very rich field when you're looking.
And you can see all globular clusters in your binoculars as well.
That's right.
It might be small, but it's very bright.
Our next object is M5. So this is the 5th entry in Messier's list of objects. M5 is also a globular cluster, and it's in the constellation Serpens, I believe. So again, it's a pretty easy find in light-polluted area. It's quite bright. It's distinct by itself. In the image, it looked like you had the globular cluster and it was relatively dark around it, and that's just the way it looks.
And globular clusters, basically, they behave similar to electrons going around the center of our galaxy. So they orbit like electrons, and this one is also the same brightness. It's magnitude 6. It's a little bit closer. It's 26,000 light years away. It's a little bit smaller. It's only 151 light years across, and it's 20 minutes in apparent size. But it does look very, very bright, and these are two of the best globular clusters.
I have heard that you can actually see M5 with your naked eye if you're at a dark enough sky site. It's on my list of things to see naked eye, and I haven't quite gotten to that yet. It also has a huge number of stars. It's estimated somewhere between 100,000 and 500,000 stars.
Yeah, and globular clusters differ from open clusters in the fact that there's so much gravity amongst all of them that rarely does you ever lose a star, whereas an open cluster dissipates over time.
That's right. And in fact, M5 is one of the oldest globular clusters that we know about. You basically age the individual stars, and that dates the cluster itself. And M5 is nearly as old as the Milky Way galaxy. It's about 13 billion years old. So our next object is M35. So when I see M35, M35 is the open cluster to the left on your screen. There's a globular cluster, smaller globular cluster, NGC 2158, just to the right there. But to the left, the larger object, when you're actually seeing this in the light-polluted skies, M35 is very obvious, and this small globular cluster is not very obvious. It seems to succumb to the light pollution to some extent.
Yeah, you definitely need to see a large a large telescope to see the smaller open cluster. It is very faint even in a big Dob. But M35 looks good in any telescope, and it looks good even in binoculars.
Absolutely, absolutely. In fact,
and it is easy to pan. You know, if you have a wide view binocular, it's easy to pan from M35 over to M36 and M37 and M38. The wider field of view, you can see more of the galaxies. Like one of my binoculars, I can see M35 and 36 in the same field of view, and I can also see 36, 37, 38 in the same field of view, which I believe is going to be our next ones in the series. Right.
Right. So M35 is in Gemini, and then 36 and 37 and 38 are all in Auriga, but they really are almost in a line with each other, and I like to look at them basically in a single sitting, just one after the other. I usually go with the M35 first, not just because it's numerically lower, but because I find it easier to find it. Gemini is a very prominent constellation. Castor and Pollux are very bright stars, and you just look to the foot of Gemini, and it's pretty easy to spot.
And my daughter plays soccer, so I always think of it like kicking a soccer ball, M35.
Right, and you can think of M36, 37, and 38 as the ball moving in that direction.
Yep.
So
let's bring up M36.
So M36 is an open cluster, and it's in Auriga again. It's about 4,000 light years away, and it's thought to have at least 60 members, that is, stars that are thought to be part of the actual moving cluster, moving all together.
Yeah, so this isn't as bright as M35. It's magnitude 6. It's 12 minutes in apparent diameter and 14 light years in real life. But it is a very bright, impressive one.
Yeah, this whole chain of open clusters are favorite objects of mine. So let's move on to M37. M37 is also in Auriga. It's a bit richer. There's a little bit denser grouping of stars in M37, and
this one's a little bit further away. It's 46,000 light years. It's 21 minutes across, so it's bigger. 32 light years in actual size, and this one is pretty bright as well.
There is kind of an interesting feature of M37. It's in exactly the opposite direction of the center of our galaxy. So this is looking straight out of our galaxy with the center behind you. So you won't see them both at the same time. Obviously, the Earth will be in the way.
Okay, the last one in the series is M38, and M38 is the faintest of all four open clusters. It's magnitude 6, 42,000 light years across, 21 minutes in apparent size, 26 light years in the actual size.
Mm-hmm. So those are the open clusters. We're going to take a break. If you have any questions about the deep sky objects or anything that you have about our show, send us an email. The email address, astronomyforeveryone@gmail.com. It's pretty easy to remember. We'd like to hear your email. Next up is Term of the Month with, well, I guess I'm doing Term of the Month. Be back shortly. The Term of the Month for March 2013 is Saturn. Saturn is the new evening planet, really. We're losing Jupiter, we're getting Saturn. This first image is pretty much what Saturn looks like in a backyard telescope. This picture was in fact taken using a camera on a backyard telescope. So the rings are tilted way over. You can often see the Cassini division, that's that dark ring. Saturn is a gorgeous, gorgeous planet. We also have a mission to Saturn. the Cassini mission. It's a probe that's orbiting Saturn. It carried the Huygens probe, which landed on Titan, which got great images of the surface of Titan. So what you're seeing here is rocks made out of water ice. It is so cold that the ice is hard as granite on the moon Titan. The moons of Titan are gorgeous. There are like 5 really good moons to see in your backyard telescope. The term of the month for March 2013 is Saturn. Welcome back to Astronomy for Everyone, where we're talking about spring deep sky objects. These are objects that you can see in the night sky in this month of March. Our first object is M44, which is an open cluster. It's a gorgeous open cluster, and it's also called the Beehive cluster. Now, this image doesn't do it justice. When you look at it in binoculars or a scope, it is an awesome, awesome open cluster.
Yes, and this is one of the 2 best open clusters on the Messier list, the other one being M45, the Pleiades. M44, the Beehive, is magnitude 3. It's 525 light years away. It's 90 minutes across, or that's 1.5 degrees. And in real life, it's 14 light years across. This is really big. It's actually so big, I can't see it completely in my large Dob, even with my largest 40 millimeter 70-degree field of view eyepiece. I have to see it in 25 by 100 binoculars, which looks really fantastic, or a smaller telescope or binoculars to see the whole thing.
Yeah, in my 10-inch Dob, my original eyepieces, my low-power eyepiece was only 1 degree across, so it didn't fit in 1 degree. But I now have a 2-inch and even lower power. It's a 32x eyepiece, and it easily fits it in. It has a 2-degree field of view.
And this open cluster does have a lot of triple stars in it. They all look like little triangles all over the place. Looks really good in a 25 by 100 binoculars. It
is one of my favorite objects. It is very close to the ecliptic, which means that, so the ecliptic is where the sun is the path that the sun apparently goes through. Well, you normally don't see the sun with the other stars, so this is something that astronomers have calculated.
But the planets do pass through it quite often.
The planets pass through it.
That's pretty impressive.
In fact, I had a hard time finding any kind of an image that didn't have Mars or Saturn in it. It's a very photogenic cluster when you've got a planet in there, a bright planet in there as well. Next up is M51. M51 is one of the nearby galaxies. It's only how far?
The whirlpool, this is 35 million light years away. Actually, M51 is a double object. It's Messier's only double object. It consists of NGC 5194, which is the main one we think of at M94, and then 5195 is a small sister one. It's also in O'Meara's secret deep objects. It's number 67. So M51, that's magnitude 8. The other smaller one is magnitude 10. And the larger one is 11 minutes by 8 minutes, and the smaller one is 6 by 5 minutes. And the whole thing all the way across is 112,000 light years across. M51 is really impressive. It's a spiral galaxy, almost face-on, and it looks pretty good in a large Dob in a dark sky site.
Yeah, it looks very good in my 10-inch, but only at a dark sky site. From where I live at home, my driveway, the Mercury Vapor Observatory, so I've got a street light right next to me and so on. M51 is not visible at all. You can't see it. There's nothing. There's nothing there. It's all the background sky brightness is brighter than the galaxy, and you just can't see it. At Kensington, at Astronomy at the Beach, in my 10-inch. you get to see what I call a detection, which is that there's a slightly brighter patch of sky there that moves when you move your telescope, but you're not really seeing the, any details of a galaxy. In fact, it's really hard to tell that there's anything there. I call it a detection. It's not a very nice term.
So that is a telescope object, not a binocular object.
Absolutely. However, I hear that you can see it in binoculars if you have a dark enough sky sight.
Okay.
So, dark skies rule for galaxies, dark skies rule more than aperture even.
Okay.
In any case, yeah, M51 is one of the better galaxies that you can see, probably the second brightest.
Okay.
So next up is M64, I believe. M64 is another galaxy. It has kind of another name, the Black Eye Galaxy, and that's because it has these dust lanes, which kind of give it a black eye look.
Yes, it does. You can see the dark dust lane going through, and you can see that in my telescope, probably in your telescope as well.
Only if it's a dark sky sight, right? I can't see it at all otherwise, though.
It's 20 million light years away, 9 minutes by 5 minutes in apparent size, and 52,000 light years across from one side to the other.
Mm-hmm.
So it's a very impressive looking one.
So this Hubble Space Telescope image, it's from their Heritage collection, so they have a collection of their best images. So this is from their Heritage collection. This gives you detail that you probably won't see without a really substantial telescope. The Hubble has two advantages. One is that it's always in a dark sky sight. It's in space. And the other is that it's 2¼ or 2½ meters in diameter. So that's minus 1/4 meter.
So all that dark stuff, that's dust. That's basically obscuring the light behind it.
Dust in the galaxy that then,
yep,
obscures the stars in the galaxy. Sure. Next up is M65. I believe it's no, we're moving on to
M67.
M67.
This is M67, and this one is in Cancer. It's very close to the Beehive. It's magnitude 7, 25,000 light years across. It's a half a degree or 30 minutes in apparent size, 22,000 light years across.
Right.
And
so M67. It's an open cluster. Cancer doesn't have a lot in it. There's
this one in M44. That's it.
That's right. So it has these two objects, but the stars in Cancer aren't very bright themselves. So
by the way I find M44, the Beehive, is I look halfway between Pollux and Regulus, and
that's right. So we're using stars that aren't even in Cancer to find this.
Next object.
Next object. I believe that would be M81. Is that true?
Go ahead. Bring up the next object.
M81 and M82.
So the elliptical one over there, that one is Bode's galaxy.
This is on the right there.
That's M81. It's magnitude 7 million light years across, and 26 by 14 minutes, 53,000 light years. The other one, the Auriga galaxy, that's magnitude 6, but it's a little smaller. It's 11 by 5 minutes, and it's 22,000 light years across. Both of these you can see in the same field of view in my telescope. Looks totally awesome.
They are a great pair of galaxies. However, only the brighter of the two, that's the M81 Bode's galaxy, only the brighter of the two is visible ever from my house, and then only when it's relatively high in the sky. So it's nearly circumpolar in...
and these are bright enough to see in binoculars, so they look really good in the 25 by 100 binoculars, or even smaller binoculars.
Again, they're galaxies.
15 by 63s. They look good.
They're galaxies, so from a dark sky sight.
From a dark sky sight.
Right. So from my house, I can only see one of the two, even with the 10-inch telescope. From a dark sky sight, they both look awesome. So next up, I believe, is M94. M94 is a spiral galaxy in Canis Venatici. So M94, 16 million light years away, I can only see it if I'm out at a dark sky site. I certainly have seen it in my 10-inch. It's pretty good.
Okay,
like
M94 is 11 by 9 minutes, 46,000 light years across.
Okay, so Canis Venatici, for some reason, has a lot of interesting objects. I don't think of the constellation itself as being terribly interesting otherwise. So, so that's it for our deep sky objects for the month of March. And next up, we're going to have, oh, you know, you should visit our website. This is astronomyforeveryone.org. And next up is What's Up in the Night Sky? What's up in the night sky for March 2013? March is an equinox month. The 20th of March is the spring equinox, and that means that the day and the night are just about the same length. So you can expect the sun to rise around 6 a.m. and set around 6 p.m. pretty much every day in the entire month, because the days get to equal night and day more or less in the middle of the month, so they stay that way pretty much the entire month. Astronomical night is when the night is darker, right? It's after sunset to before sunrise. So that's about 7:30 p.m. to 5:30 a.m. So that's when the nights are darkest. So let's see what the moons are doing in March. We have the third quarter moon on the 4th of March. That's a Monday. So the quarters happen more or less on the same day of the week. Third quarter is when the moon is visible in the morning, that is, say, after midnight and into the morning, which leaves the sky darker in the evening. The 11th of March is the new moon, and that means that the sky is dark all the time. The new moon is hard to see, so we represent that with a black piece of screen. The 19th has us at the first quarter moon. I like to see the first quarter moon. It's an afternoon, evening sort of thing. You can see it during the day most of the time. And that's on a Tuesday, so the day is shifted a day. And then finally on the 27th, which is a Wednesday, we have the full moon. And the full moon is visible all night long. Jupiter is still the evening sky, the evening sky planet. On March 17th, this image shows Jupiter right next to the moon. They're going to be really, really close there in Taurus together. And Jupiter is, you know, it is up until about 8 p.m. So we're losing Jupiter, but Jupiter is still, you know, the king of the planets. A little later, about 10 p.m. or 11 p.m., Saturn rises in the east, and Saturn is in Libra. They're on the right side of your screen. So you're looking east to where things rise. Saturn has its gorgeous rings. The rings are tilted quite a ways over, so with a good telescope you can see things like the Cassini division and other bits of interesting stuff in the rings themselves. mostly in a backyard telescope, the planet itself is this sort of dull yellow color, and it's hard to see real detail on it, but you can sometimes see, you know, some of the storms and stuff on Saturn. Usually it's mostly just pale yellow. But Saturn has a number of moons, and my logs show that I variously see Titan and Rhea and Dione and Iapetus and Tethys. And these moons sort of do a dance around Saturn. It's predictable because they're orbits, but they're a little different. Iapetus is sometimes darker and sometimes lighter, so sometimes it sort of disappears on you. Iapetus is one of my favorite moons in the whole solar system. It's just so weird. If you look straight up at 9 p.m. in the middle of the month, there are two main constellations. Gemini is the twins, so the heads are Castor and Pollux, and Auriga. So this image is, if you're facing east and then look up, then Gemini would be sort of below, if you will, and Auriga would be above. But if you were facing west and then looked up, this whole image would be upside down, wouldn't it? Anyway, in Gemini, it turns out that Castor is one of my alignment stars on my telescope. And if I can't remember which is Castor and which is Pollux, when I look at Castor, it turns out that it's an easy double star. My telescope splits it. Pollux is not an easy double star, so they're distinguishable. Auriga has the bright star Capella, which is part of the winter hexagon. Epsilon Auriga is a variable star with an extremely long period, and it was studied recently because it has such weird behavior. We just had an eclipse period. It's like 28 years long. Finally, we have the Leo triplet, and the Leo triplet has M65, M66, and NGC 3628. These are basically left to right here. So 66 is the one that's on top and the lower one. Now the NGC 3628 is hard to see. You really need a very dark sky sight to see it. And you need a fairly decent telescope. It's fainter than the other two. But the Leo triplet is certainly worth a look if you've got a decent telescope, or you can visit an astronomy club outreach place. And so that's what's up in the night sky for March 2013. Keep looking up.